Hello, how are you? Welcome to my channel. I'm Mrs. Tendere and I'm continuing. Today we are starting with the grade 12s. The grade 12s are not forgotten. We are starting with you guys with our mid-latitude cyclones. And before we look at our mid-latitude cyclones, we need to know where these mid-latitude cyclones occur and what they are. And we always need to go back to our grade 11 geography. We need to know our pressure belts. Remember our four main pressure belts in grade 11. We said they influence the weather systems on the Earth's surfaces. So when we look at mid-latitude cyclones, these are centers of low pressure that occur at the subpolar low pressure. That's why I just highlighted the subpolar low pressure for you, where we have our westerlies meeting up with our polar easterlies there. When these polar easterlies meet up with the westerlies, they don't mix, and what do they form? They form what is called a polar front. And it is within this region where we have the mid-latitude cyclones occurring. Okay, so this is grade 11 linked up with grade 12. Now, what are the general characteristics of a mid-latitude cyclone? Mid-latitude cyclones, they can also be called frontal depressions. They can also be called extratropical cyclones. They move, in terms of direction of movement, they move from west to east. Air moves in a clockwise direction around the center of the low pressure in the southern hemisphere. And if it is in the northern hemisphere, then it means direction of wind will be in an anti-clockwise direction. They occur in families of 3 to 4. Areas of formation, like as I said and I've indicated for you on the global air circulation diagram, they develop at the polar front, which is around about 40 to 60 degrees north or south of the equator. I hope this is in order. And why do we look at these mid-latitude cyclones? Why do we look at them? In South Africa, they do occur in South Africa. That's one thing you should note. They do occur in South Africa. And which part of South Africa? It is the southwestern Cape. Our southwestern Cape. Remember we said it is around about 40 to 60 degrees north or south of the equator. So they do impact on weather conditions that we experience in South Africa. And remember, in South Africa, in the southwestern South Africa, they occur in winter, isn't it? They occur in winter, and I think that's why you know why we tend to experience more rainfall in winter. Now, what are the conditions necessary for formation? Conditions necessary for formation. Conditions necessary for formation of these mid-latitude cyclones. We need to have warm westerly wind meeting with the cold polar easterly wind. Warm wind is less dense, so it is pushed by the cold air upwards, and the cold air sinks onto the surface. These are the conditions necessary for formation, and obviously it has to be between 40 degrees to 60 degrees north or south of the equator. In some books you'll see they also mainly specify 50 degrees north or south of the equator. Right, so for these mid-latitude cyclones to develop, they go through What are the stages? Before we look at the stages, you should know that these tropic mid-latitude cyclones, they develop between 2 to 5 days of the normal week. The first stage of development is what we call the initial stage. Now, what happens here at the initial stage is we have the westerlies moving in one direction, and the polar easterlies moving in another direction. But when they meet, these two air masses when they meet, they do not mix. Hence, they form a polar front because they have different characteristics. One is warmer, one is less dense. One is warmer, which is the westerlies, and it is less dense, and one is colder, which is the colder air. So here we have the polar front forming. Then stage number 2 is the development stage. The development stage. What happens now here at the developmental stage? We are going to have frictional drag at the center here. There is going to be frictional drag between the air masses. Disturbing the front. And it forms a wave, as you can see in my diagram there. And now here at the center, now here where we have the frictional drag, that's when we are going to have our center of low pressure. And what is going to happen here now? Warm air will rise up now. Cold air starts to sink. So we have a low pressure forming here at the center here. The third stage would be the mature stage. third stage will be the mature stage. Now here we tend to see both fronts evident. Sorry, let me draw it nicely. We have the cold front, which is represented by triangles that are shaded, and we also have the warm front indicated by semicircles, and this is our center of low pressure at the center. Air starts to move in a clockwise direction, as we can see there. So what's happening? Air starts to move, or we can say to rotate in a clockwise direction. Air starts to move in a clockwise direction. And this is around the center of the low pressure. Now what happens is that cold air is heavy and dense. So it pushes the warm air up in the atmosphere. And it is easy for warm air to move upwards in the atmosphere because it is less dense and it is lighter. So warm air rises over the cold air. Fronts now, because air is rising, both fronts are associated with uplift and possible rain. Because when warm air rises above the cold air, condensation will take place, and we are also going to have rainfall. This is the cold front. This is our center of low pressure. And this is the movement of our winds in a clockwise direction because we are in the southern hemisphere for us here in South Africa. So we are now experiencing heavy rains during this particular time. At the fourth stage now, we have what is called the occluded stage. What other name can be given to the occluded stage? Okay, this occlusion stage, how does it appear on the synoptic chart? The occlusion stage appears something like this on the synoptic chart. We have the cold fronts here. We have the warm front here. And we also have a mixture of the warm front. That's what we call the occluded stage. And before I look at this, remember this center is known as the warm sector. Now at the dissipating stage, what happens is that all warm air will be uplifted in the upper levels of the atmosphere. So if all warm air is uplifted in the upper levels of the atmosphere, it means at the surface, what remains is the cold air. Isn't it? So this is our cold front. This is our warm front. This is the occlusion. And this is our warm sector. So it means also our warm sector narrows as we reach into the occlusion stage. And the fifth stage, I'm so sorry, no space here, is going to be the dissipating stage, where our mid-latitude cyclone weakens. So I've taken you through the stages of the mid-latitude cyclone. So I'm going to end here for today. In my next video, I'm definitely going to continue with the mid-latitude cyclone, where I look at the weather patterns and how you can identify them on the satellite images. Right, I hope you find this in order. Keep on subscribing and watch me again in the next video. Thank you.